Now, when we talk about mole, let us get to understand what a mole is. The mole is actually the number of particles in a given substance, and that number of particles is referred to as the Avogadro's number or Avogadro's constant. So what it literally means is that 1 mole of any substance has Avogadro's number of atoms in it. For example, 1 mole of carbon contains 6.02 times 10 to the power 23 atoms in it. 1 mole of water molecule also has 6.02 times 10 to the power 23 water molecules. 1 mole of sodium chloride will have 6.02 times 10 to the power 23 sodium ions, and the same number for chloride ions. So what it simply tells us is that 1 mole of any substance will have 6.02 times 10 to the power of 23 particles inside it. These particles may be ions, atoms, or molecules, or even electrons. So we have said it is called Avogadro's number or Avogadro's constant. Now, talking about stoichiometry, we are going to be looking at some formulae that are of utmost importance to discussing stoichiometry. And this formulae makes use of the relationship between mole and other parameters. So we have the relationship between mole mass and molar mass as N equals M over mm. That is to say, mole, small letter n, equals mass over molar mass. N is also equal to number of particles over Avogadro's number. N is also equal to concentration times volume over 100, over 1000, I beg your pardon. N is equal to volume over molar volume, and N is equal to concentration times Avogadro's number. So these relationships are very, very useful, as we are going to be seeing how we make use of them. The relationship between mole and other parameters. Let us proceed now to discussing valency. Talking about valency, we have heard of this word in our previous videos. Let us recall to us again that valency is the combining power of an element. That is to say, the valency of an element is equivalent to the number of valence electrons it has in its outermost shell. Just like we can see in the animation on the screen, seeing the number of electrons rolling through the shells, the last electron in the outermost shell of any element tells us the valency of that element. So valence electrons gives us the valency of a given element. Let us therefore get to understand what this valency is and what is the valency of different elements. Generally, hydrogen and other metals have positive valencies. Why? It is because they tend to give out their electrons, their valence electrons. Why non-metals have negative valencies? Sometimes, however, a group of atoms combine to form a single unit which is called radicals. The valency of radicals may be positive or negative, depending on the individual atoms that make up that group, that radical. Let us take a look at some examples of valencies. So looking at the display on the screen, we can see the valencies of different elements. Some elements are having just one valency and some others are having more than one valency. So these are the valences of these elements, and these valences play a very crucial role in their bonding, in chemical bonding, and any reactions that they are going into. Iron is having 2 or 3, lead also plus 2 or 3, carbon plus 2 or 4, sodium plus 1, copper plus 2. Going to the other side, the anions, the non-metals, they have nitrogen is having minus 3 or 5, oxygen minus 2, fluorine minus 1, phosphorus minus 3 or 5. So these are some examples of valences for different elements. We shall get to know how these valences play crucial role in the chemical reactions that these elements are actually involved in. Let us take a look at the valency of radicals. Radicals could be positively charged or negatively charged, and when radicals are having negative valences, they are actually classified as anions. A good example is triazocarbonate 4 ion, which is having a valency of minus 2. Ammonium ion is also radical with plus 1. The sulfate 6 ion is having a valency of minus 2. Hydrogen triazocarbonate 4 is the bicarbonate ion is negative 1. Hydroxide ion is also negative 1. So these are few examples of the valences of radicals in chemistry. We shall get to learn more about the valences of radicals and both the cations and anions. Okay, away from radicals, we shall now be looking at what we call symbols and equations. Talking about symbols and equations, this will actually help us to know the usefulness of the valences of elements or radicals, which we just talked about. Now, when 2 or more elements combine to form a compound, they usually exchange their valences. So you can see the usefulness of valences of different elements. These valences play a crucial role in reactions, and when these elements react to form a compound, these valences are the species, they are the substances which are exchanged for this compound to be formed and thus have a molecular formula. Looking at the example between sulfur and sodium. Sodium is having a valency of plus 1 and sulfur is having a valency of negative 2. When these two elements come together in chemical combination, they exchange their valencies. The sulfur valency goes to sodium and the valency for sodium goes to sulfur. And as such, we have a compound formed which is Na2S. It is worthy to note that the charges associated with these valencies do not go together with the valencies. That is to say, the plus for sodium, the plus that is attached to 1 does not go with the 1. And for sulfur, the sign, the negative sign, does not go with the 2. So they just exchange the valence numbers and we have the compound. So Na2S is called sodium sulfide. Look at the second example between aluminium and chlorine. Aluminium is having a valency of plus 3, while chlorine is having a valency of minus 1. In any reaction, they exchange their valencies and chlorine takes up the valency of aluminium, while aluminium takes up the valency of chlorine. And we have that compound formed AlCl3, and that is called aluminium chloride. Let us take a look at more examples for which symbols and equations are formed as a result of the exchange of valencies. This is between iron and phosphate ion. When phosphate ion comes into reaction with iron and mixing to form a compound, we have the Fe3 plus coming in contact with PO4 3 minus. It is worthy to note that the 4 is a subscript. So what we're going to have is the exchange of valences. But in this case, since their valences are the same, phosphate ion is having a valency of -3 and iron is having a valency of +3. Since their valences are the same, they can cancel out each other, and we have FePO4. In the case of calcium and chlorine, calcium is having a valency of +2, chlorine is having a valency of -1. So in any reaction, they exchange their valencies and we have that compound form CaCl2, which is called calcium chloride. So this is the essence of valency. That is the importance of valencies of elements, or that for radicals. It actually comes to play when these elements come into reaction. As they come to reaction, they exchange their valencies and it leads to the formation of a compound such that the compound has a formula.